Hello everyone, myself Snehal Shinde, lecturer in Pravin Patil College of Diploma Engineering and Technology from Electrical Department. Subject is Utilization of Electrical Energy. Subject code 22626. Unit 4 Electric Traction. Next is the quadrilateral speed time curve. So the speed time curve for urban suburban service is approximated to the quadrilateral speed time curve and it is as shown in the figure. So for urban suburban service speed time curve, it looks like a quadrilateral shape. So now we will make the assumption on the quadrilateral shape. So while drawing this diagram, speed versus time curve. So V1 is the maximum speed at the end of the acceleration. T1 is the acceleration time in second. Alpha equal to acceleration in kilometer per hour per second. V2 is the maximum speed at the end of the coasting in kilometer per hour per second. T2 equal to the coasting time in the second. Beta 0 equal to the coasting retardation in kilometer per hour per second. Beta equal to the braking retardation in kilometer per hour per second. T3 equal to the braking time in second. Capital T equal to the total time of run in seconds. S equal to the total distance travelled in kilometer. So acceleration equal to the change in velocity during acceleration divided by time for acceleration. Alpha equal to the V1 upon small t1. Therefore T1 equal to the V1 divided by alpha. Then coasting retardation. So change in velocity during coasting upon time for the coasting. Beta 0 equal to V2 divided by T3. Then T3 equal to the V2 divided by beta. So V2 equal to the V1 minus beta C into T2. So V2 equal to the beta C divided by beta V2. And then V2 equal to the V2 minus beta C T minus T V1 alpha. So V2 equal to became, while we simplify the equation, then V1 minus beta C T plus beta C divided by alpha into V1 divided by 1 minus beta C divided by beta. Also the T2 value will become V1 minus V2 into beta C. So the total time of run capital T equal to T1 plus T2 plus T3. Area under the curve gives the total distance travelled. So area OABC equal to S. So the distance travelled during acceleration in kilometer equal to the area of triangle OAE equal to the half into T1 by 3600 into the V1. Next is the distance travelled during the coasting in kilometer. So equal to the area EABD. So the area of the rectangle EFBD plus area of the triangle FAB. So V2 into T2 divided by 3600 plus half into T2 3600 into V1 minus V2 equal to the V2 into T2 divided by 3600 plus V1 into T2 divided by 7200 minus V2 into T2 divided by 7200. So while simplifying or taking the base as a 7200, we get 2 into V2 into T2 plus V1 into T2 minus V2 into T2. Now, so by simplifying 2 V2 T2 minus V2 T2, we get V2 T2 and plus V1 by T2 into 7000. So here distance traveled during coasting in kilometers. So we have simply taken the area, that is area EABD. So it resembles the area rectangle EFBD plus the area triangle FAB. So we have put a rectangular formula, that is length into breadth, and here we have simply put the half base into height formula of the triangle FAB. Then we have substituted the values of it, simplified it, and we get V1 plus V2 divided by T2. So into, we have kept this term here as it is, and this term we have separated this two terms. Now the distance traveled during coasting retardation is half into T3 divided by 3600 into V3. So the total distance traveled, that is denoted by S, it is given by distance traveled during acceleration plus distance traveled during coasting plus distance traveled during the retardation or the braking. So from equation 3 we can write S equal to, now simply we have to put the values of the equations. So we will put half into T1 3600 into V1 plus V1 plus V2 divided by 2 into T2 by 3000 by 600 plus half into T3 divided by 3600 into V2. So like this we will put the values of F in the equation of S. So our equation, this equation is useful for the solving numericals. So similarly we will now make it as a one equation. So we will multiply T1 into V1. So here will be T1 into V1. Then 2 into 3600, it is multiplied. So we will get T1 into V1 divided by 7200. Then plus V1 plus V2 divided by 2. So we will get this value. Again here 2 into 3600 we will multiply. Now we will get this equation. Again same here you have to perform the same like previous. So 2 into 3600, it will become 7200 and T3 into V2. So again now we have to separate the terms T1 V1 as it is, right? Then here internal multiplication, and after internal multiplication we get T2 into V1, and here T2 into V2 we will separate here. So just the separation works is done here. Then again S equal to the, now here T1 plus T2 and V1 by 7200 is the common, so take it outside, and now in bracket it will be T1 plus T2. Similarly here V2 by 7200 will take common, and in bracket T2 plus T3. So like this we will write the equation, and now we know that the total time of run, that is capital T, is equal to the T1 plus T2 plus 3T. So as we know the capital T is T1 plus T2 equal to the T minus T3, and T2 plus T3 equal to the capital T minus T1. So putting this in the equation, in this equation we get S equal to the V1 divided by 7200. In place of this we have to write a T minus T3 plus V2 by 7200. Here we have to write capital T minus T1. So rearranging the terms we get capital T equal to divided by 7200 V1 plus V2 minus V1 into T3 divided by 7200 minus V2 divided by into T1 divided by 7200. So like this, substituting this equation, we get the value of this. So T by 7200, since we know the T3 value. T3 value is V2 divided by beta and T1 value is V2 divided by beta. So we will substitute the value of T1 and T3 in this equation. Okay. So now we get 1 minus 1 upon beta and V2 is written over here. Then minus V1 into V2 upon alpha. Now S value will be T upon 7200 as it is, V1 plus V2 as it is, minus. Now just we have multiplied 1 upon beta in this equation. So we have multiplied it, and now the 7200, take it as a common and it will go on the left hand side. So the final equation will be 7200S equal to the T V1 plus V2 minus V1 into V2 1 upon alpha plus 1 divided by beta. We will get this value. Now next is the overhead current collectors. So the contact between current collector and overhead equipment should be maintained under any circumstances. The contact wire in all practical installation is never perfectly horizontal. It may raise or fall depending upon the weight of the contact wire and the distance between the droppers. The contact wire comes very low under bridges and tunnels and raises high over public crossings. So the current collecting system or gear has to accordingly raise and fall in order to maintain the proper contact with the overhead equipment. So the choice of overhead current collector depends on the speed of the vehicle and the construction of the overhead equipment. So this is the overhead current collector. In this overhead current collector, as we have seen in the block diagram of the AC locomotive, in this we have seen the current collector. So there are two mainly current collector system, namely the current collection from the conductor rail or the third rail and the current collection from the overhead equipment. So the current collection from the overhead wire is far superior compared to the third rail arrangement. This is because both the theoretical and experimental current collection is more difficult from a rigid body than from an elastic one. So here is the types of the overhead current collector. We have to see its diagram and what is the working, how it is erected over there. So we have to see here. So the types of overhead current collector are pole collector, then bow collector, pantograph collector. So like this, we will see in detail about this. So third rail, as I mentioned, third rail or conductor rail system and overhead or pantograph system. So this is the comparison we will see in detail. So this is the pole collector diagram. Here the pole collector diagram is there. And then there is a bow collector diagram. Then again there is a pantograph. Then in overhead equipment, polygonal overhead equipment. Then single catenary construction. Then compound catenary construction. These are the types of the pantograph collector overhead equipment. And then in pantograph there is a diamond type shape and it is also having a cross arm type. Then stitch catenary construction. So yes, there is a different types of the overhead current collector. So in next lecture we will see the different types of the overhead current collector and its diagram with its how it is done. Thank you.